Okay guys, now we are looking on the topic of structure loads. Loads is referred to a forces, deformations or acceleration applied to a structure's members. On the previous lecture, we already know what is the difference between structure and structure members. So each structure members are carrying a loads. Okay, and load can cause stress, deformation and displacement to the structure members, and the assessment of their effect or the effect of load is carried out by methods of structure analysis. That's why you have to know on how to do the structure analysis, and for ECS 444 at least you should know on how to do a structure analysis for a simply supported beam. The excess load or overloading may cause the structures to fail. At all conditions, we as the engineers have to design the structures to be safe. In order to make it safe, we have to make sure that the design load is greater than the applied load. In designing a structure's member, the load can be classified into few names such as ultimate design load, permanent loads or also known as dead load, variable loads or also known as live load. We may have environmental loads such as wind load, snow, and then we may have uniformly distributed load or also known as UDL in the structure analysis. We may have a point load, we may have a compression load, tension load and bending load. In designing a structure member, most of the standard used by the engineers are following or referring to ultimate limit state design. In ultimate limit state design, we are using ultimate design load. What is meant by ultimate design load is the load that been multiplied with a safety factor. As an example, in the slide, we can see that the ultimate design load is equivalent to 1.35 GK plus 1.5 QK. This is only an example. 1.35 is referred to safety factor for permanent load, while 1.5 is referred to a safety factor for variable loads. And GK is a symbol for permanent load, and QK is a symbol for variable loads. As told before, there's other type of loads such as wind load, seismic load, snow loads, and etc. But for this syllabus, we are only focusing on loads of permanent and variable loads. Okay, this slide presenting an example on how we are calculating the ultimate design load. Say we have a permanent load and variable load acting on a beam as 10 kN per meter and 5 kN per meter respectively. Or mean to say that the permanent load is 10 kN per meter and the variable load is 5 kN per meter. So on how we are going to calculate the ultimate design load is by multiplying the loads with the safety factor. So in the example, we can see that the design load is equivalent to 1.35 multiplied with GK plus 1.5 multiplied with QK. Since the GK value is 10 and the QK value is 5, after we multiply and plus the value, we get the ultimate design load as 21 kN per meter. Okay, now let us look on what is meant by permanent load. Permanent load is a loads that includes loads that are relatively constant at over time, such as weight of the structures itself or self-weight of structures, the immovable fixtures such as wall, plasterboard, shielding, tiles, and etc. The roof is also permanent load, okay, and the permanent load also known as dead load or static load. Okay, the building materials is only considered as a dead loads if it was constructed as a permanent members. Okay, as an exercise, I would like you to identify and list at least 10 density of construction material that normally been used in the construction industry. Okay, from this exercise, you may find the density of material, and afterward, in the calculations of load, I will show you on how to use this material density to calculate a permanent load. Okay, the next item is on the variable loads. So what is variable loads? Variable loads is also known as live loads, or sometimes they call it imposed load. They are a temporary loads or being allocated to the structure's members for a short time durations, and the loads also is movable. Variable loads also refer to all forces that are variable within the object's normal operation cycles. Roof and floor live loads are produced during maintenance by workers, equipments and materials, and during the life of the structures by movable objects such as planters and peoples. Okay, so in the bridge structures, the live load is referred to the vehicles that are moved along the deck of a bridge. Okay, in this exercise, I would like you to identify and list a value of 10 variable loads that is available in the standards. You can get this value from the internet, Google it, find it, and list the variable or loads. Afterwards, I will teach you on how to use the variable loads value in calculating the ultimate design load.